Okay, any questions before we start?
Okay, not by doing what everybody else.
So I know the test was available. I think I extended the deadline for the test. Let me see. But some students, they still have not taken the test. Where is the test here? Yeah, it's tonight midnight. It's supposed to be yesterday, but I extended the deadline for tonight. So make sure you take it before midnight tonight. I see that 4 or 5 students still have not taken the test. Make sure you take it before midnight tonight. Okay. Any of those who missed the test in the meeting now?
Um, is
Yeah.
it different tests or is did I take this test? I'm not sure.
Hmm?
I said, is it two different tests? Because I took a test yesterday, but I see that on my thing today
Oh,
too.
maybe you took the practice test. I don't
No,
know.
I ain't taking no practice test.
Oh, you took the practice test?
Nah, I took a real test.
Yeah,
Well,
the real test there, that's fine. I don't want to show the grades for everybody. I can open it, but I don't like to show
it was like
everybody
30,
grades.
36 questions, right?
I think, yeah.
Uh,
Yeah, if you check the grade book, if you have a grade, that means you took the test. If there's no grade, that means you have not taken the test. Okay. Okay. Again, some students, I don't know if they are from this class or another class. When we use the lockdown browser, they if they use a laptop, it's hard to use the lockdown browser uh, with the laptop. I think, if you don't have a computer, you can go to the computer lab and take it, or like borrow a computer from somebody, because some students, they said they only have the iPad, and it's hard to take it. I don't know, it's not compatible. The version that we have, which is provided by our school, is not working with the iPad. But keep trying, and if you end up with cannot take it, just let me know. Okay, we will find another way. But this test designed to be taken with the lockdown browser, so okay. Let's see. So last time we talked about slack time, and we calculated the slack time for this project, and we said the critical path includes the activities with zero slack time, and we ended up that our uh, critical path for this project is A, C, E, G, H, where all the activities have zero slack time. So that means if any of these activities delay, this will delay the whole project, okay? So now we will learn how to find the standard deviation, and we will study the variability in activity times. So CPM assumes we know a fixed time estimate for each activity, and there is no variability in the activity. And actually, there should be a variability. Sometimes it's fixed, but most of the time there should be some variability. PERT uses probability distribution for activity times to allow for variability. So variability in activity times, three time estimates. We will use what we call the optimistic time, which is optimistic from the name. That means everything goes well according to the plan. So this is the optimistic time, that we will finish this activity during the activity time. Okay, the estimated. Pessimistic time, assuming very unfavorable conditions. So the activity will be late. It will take more time. Most likely it's time where we use n, so it's more realistic estimate. Okay, how do we calculate the expected time for activity if we are given the A and M and B? We said we have A, B, M. So A refers to the optimistic time, B to the pessimistic, and M to the most likely. So if we are given these times, we can calculate the expected time for the activity. So the expected time is weighted average. So we give A 1A, plus 4M's is 5, plus 1B is 6. That's why we divide by 6. So it is 4M plus B plus A divided by 6. Okay, this will give us the expected time for activity. Then we can calculate the variance of activity for the completion time, which is equal to B, the pessimistic, minus optimistic, divided by 6, and this will be squared. Okay? This will give us the variance for that activity. Okay, let's see. Okay. So for example, if we are given the activities in the same project, we are given A's, M's, and B's. Okay. As we know that the variance for activity A can be calculated using B, which is this. Here's B. Oh. B, which is 19, minus A. I divide this by 6. So 19 minus 10 is 9. Divided by 6, 1.5. So 1.5 is squared. So this will give us the variance for activity A. I do the same thing for all activities. I think I have the Excel sheet for this. Let me see if I have the Excel sheet. Let me see. Yeah, I don't know. It's slow for some reason. Oh, okay. Oh, this is for another example. This is also for another example. But we can do copy this data, take it to Excel, paste it here. Okay. And then we say this is variance. We said it is equal to B minus A, right? We divide this by 6, okay? And then we take this, we square it. So this will be the variance for each activity. Now I scroll this down. Now I have the variance for each activity. So our goal, why we're doing that? We are doing that to calculate the variability for the project. Why we need that? Because let's say we have a project and we said we will finish the project in 16 days or 15 days. Okay, but nothing perfect. So if you have been asked, what is the probability that the project will be finished or completed in 15 weeks or days? What is the probability that the project will be completed in 20 days? So you need to answer this question. To be able to answer this question about the variability of the project, you need to calculate what we call the standard deviation, because in statistics we use standard deviation, sigma or S. We said sigma is the standard deviation for population, S is the standard deviation for a sample. So to be able to find the probability of completing a project at a specific time, we need the standard deviation. To calculate the standard deviation, we calculate the variance. The variance is sigma square or S square. Okay, so let's see how we calculate the standard deviation for a project. So now, this is the most likely. This is the optimistic. The optimistic means, oh, we finish this activity very early. This is the most likely that we will finish this activity. Oh, this is the pessimistic time, B. We finish it late, okay? So now we will learn how to calculate the probability. So this is another example here from table 3-4. If you go to your textbook, you will find this table. So we have activity A, B, C, D, E, F, G, H. Optimistic time, for example, for each activity is given. Most likely is given. And pessimistic is given. So now we can calculate the expected time, which is A plus 4M plus B. So for example, I will calculate one of them. For activity A, we have A is equal to 1 plus 4 times 2 plus 3. I divide everything by 6. So 1 plus 8 is 9. 9 plus 3 is 12. 12 divided by 6 is 2. This is how we get this. And we calculate the variance. The variance for each activity is calculated B minus A divided by 6 squared. So B here is 3. Minus 1 is 2. Divided by 6, 1/3. 1/3 squared is 0.11. And I can do this using Excel. If I go back to Excel, let me see if I have the same number here. Oh, I'm supposed to copy here. Copy. Oh, we have up to H here. Fixed. So we said, let's take one of them. 1, 2, 3. I put 1, 2, 3. Yeah, it calculates the variance for the activity. I do the same thing for all activities. Now, since we have the variance, this variance for each activity, okay? So the point 11 is the variance for activity A, the point 11 for B, the point 11 for C, the point 44 is for D, okay? So then we need the project variance, which is, as we said, sigma square for the project. Sigma square for the project, which is called the project variance. This can be calculated using the variances of activities on the critical path. So the critical path. So as we said, the critical path is A, B. It depends. So for our example here, the critical path is A, C, E, G, and H. So I add A variance plus B, A, C variance plus E variance, which is 1, plus G variance, which is 1.78, plus H variance, which is 0.11. Then I will end up with 3.11. This is the sigma square for the project is equal to 311. And now we will calculate sigma is equal to the square root of 311. The square root of 311 is 1.76. So now we have the standard deviation for the project, which is 1.76. Okay. So using this, we can calculate the probability we will finish the project in 15 weeks, 10 weeks, above, below. Okay. Any questions before we calculate the probability?
No question.
Okay. So let's move on. Probability of project completion. PERT makes two more assumptions. Total project completion times follow normal distribution. That's an assumption. And activities times are statistically independent. So based on that, we can put the information. So the standard deviation here, you remember in statistics, when we have a normal distribution, it will look like this, bell-shaped, with the mean or the average in the middle, and we are given the standard deviation, which is S or sigma for the project. So now it's easy. I can say, oh, what is the probability that we'll finish the project in 14 weeks? What is the probability that we'll finish the project in 17 weeks? It's easy because I have normal distribution, I have the average, and I have the standard deviation. So we will use the standardized value, find it, go to the table, find the probability. Let's see how we do that. Okay. Find Z value. So what is the probability that this project can be completed on or before 14 weeks deadline? Okay, find Z, as we said, 14 is here. So the Z value for 14 is equal to 14 minus, she said 16 weeks. The question said 16. Oh, here for 16. Yeah, it's the same. Let's see. Let's find for 16 and then we'll find for 14. So for 16 minus 15 is 1 divided by 176 equal to 0.57. So where Z, this is the Z value, the standardized value for week 16. How many standard deviation? So where Z is the number of standard deviation is due date. So then we go to the normal table and find the probability for 0.57. Let me see if I have the full table here. It should be. Okay. Did I posted the table here. Yeah. Let's see. Where did we put the table? Okay. I will post the table for you. I have it on the website somewhere, but normal table, it is here. Okay. Let's save a copy. I'm sure it is somewhere here, but I couldn't find it now. So let's say we are in chapter 3. Oh, it is here in chapter 3. Huh. Look for the second digit. So the intersection between them is this value. So the probability that we will finish this project in 16 weeks is 71.57%. Okay. Let me put this table. Yeah, let me put this table on the class website under, I'm sure I have it somewhere. Oh, let me put this here so you can use it. Here it is. Now you have it here. Okay, let's now calculate for 14 weeks. What is the probability that we will finish this project in week 14? For week 14, we need the Z value for week 14, which is equal to 14 minus the average. How much was the average? 15 weeks divided by the standard deviation, 1.76. So this will give us 1 over 1.76, negative 1, right? Which is negative 0.57. Okay. I go to the table. I look for negative 0.57. This is the negative 0.5 again. This is the 7, I think. Yeah. So the probability is this 28.43%. That's the probability that we will be finishing this project in week 14. See, I put the explanation here. So if you want to use the table, don't use this. This is a sample screenshot from the whole table. So use this one. Okay. This is the just explanation to what we did. Okay. Variability for any questions?
No.
Yeah, no questions. Okay, so we can calculate the variability of times on for activities on non-critical must be considered when finding the probability of the project. Variations in non-critical may cause change sometimes if it's high variability. So what we did here, we calculated the critical path for and the slack times for Milwaukee paper project. After we calculated the, let me remove these lines here. So, so we said we calculated the forward time, the backward times, early finish, early start, late finish, late start. Then we calculated the slack times. You see the slack time, this minus this, 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 this minus this. Where the slack time is 0, this is the critical path. Okay, so A, C, E, and then G and H. This is the critical path. And then we calculated the variance for each activity. Then we calculated the variance for the project. Then we calculated sigma for the project. And then we calculated the probability of finishing in week 14 and week 16. Okay. So that's what we did here. These are advantages of CPM path methods, useful when scheduling and controlling a large project, straightforward concept, and it's not complex, it's easy. Critical path and slack times analysis help pinpoint activities that need to be watched. Also, these are the advantages. Limitations, project have to be clearly defined, of course. The relationship between activities must be clear. Time estimate tend to be subjective. Okay, as I mentioned, we are not going to use, this is using the Microsoft project management. See how it looks like. I used to have the license for the Microsoft project, but I don't have it anymore. Otherwise, I will show you an example. It will show you each activity because, you know, in this class, we just covered project management in 1 week, so it's not a project management class. If it is a project management class, I will use the Microsoft Project Management software or Primavera. I'm sure in a project management. You see, I did the same project here using the when I had the license before. I don't have it anymore, expired. So that's chapter 3. Any questions? Oh, I put the normal tables here. There is a homework and quiz for chapter 3 on MyLab. So make sure you take this homework, finish it. I think, I don't know when the deadline is, October something. It's slow today. Oh, it's still until 25. Oh, let's change it since it is 25. So tomorrow, since we finished the chapter, you can. Why it says 25 and I have 22 here. Oh, this is the quiz. Oh, okay. Let's change it. If you want to take the quiz, take it. But take the homework before the quiz. Next time. Oh, I stopped the share. I need to stop the recording. Any questions?
No.
Okay, no questions. So we'll see you on Monday.
Thank you. Have a good day.
Thank you. Have a great
You too.
weekend.
Thank you.
Have a great day.
You too. Thank you.